Hello guys, I hope you're well. Today we're going to be solving compound inequalities. Let me show you what this means. So let's say I'm thinking of a number, I add 3 to it, and my answer is greater than 4 but less than 10. My question to you is, what could my number have been? Okay, so similar to what I'd done a couple of lessons ago, I'm going to start off by just drawing a table to get us thinking. Okay, let's try the number 1. Does the number 1 work? Well, 1, if I add 3 to it, that gives me an answer of 4. Is 4 greater than 4 but less than 10? No, 4 is not greater than 4 because it is 4. So 1 does not work. That doesn't fit my problem. Let's try the number 2. 2 add 3 makes 5, and 5 is greater than 4 but less than 10, so that does work. So 2 fits my problem. Okay, so what about the next few numbers? So 3 add 3 makes 6, so 3 works. 4 add 3 makes 7, 4 works. 5 add 3 makes 8, so 5 works. What about 6? Well, 6 plus 3 makes 9, and 9 is still less than 10, so 6 works. What about the number 7? Well, 7 plus 3 makes 10. 10 is not less than 10, so 7 doesn't quite work. If I were to keep this going, you probably notice that any number above 7 just won't work. So for example, if I'd done 8 plus 3 to get 11, 8 is too big. But my question to you now is, what's the smallest number that works? So take a moment to think about this. What is the smallest number that fits this problem? Okay, believe it or not, the answer to my question here is not 2. Okay, I can think of a smaller number than 2 that fits this problem. What about something like 1.5? If I've done 1.5, add 3, well, that equals 4.5. 4.5 is still greater than 4, so I can say that 1.5 does fit this problem. I can get smaller than 1.5. I can go 1.1, for example. That will give me an answer of 4.1. So 1.1 does fit this problem. So when I think about the smallest values that work, it's not just the number 2. 2 is the smallest integer, so 2 is the smallest whole number that works. But I can go right into those decimals and I can keep making them much smaller as long as I don't touch 1. As soon as I reach 1, this problem just breaks down and it doesn't work anymore. Okay, well, my other question to you is, well, what is the greatest number that works? So again, I'm going to give you a chance to think about this. What's the greatest number that fits this problem? So believe it or not, the answer to this question is not 6. I can think of a number greater than 6 that still fits this problem. So for example, I could have chosen, say, 6.5. 6.5 and 3 gives me 9.5. That is still less than 10, so 6.5 works. I could go higher than that. I could go 6.99. Add 3 to it, that gives me 9.99, and that is still less than 10. I can keep that going. I can get infinitely close to 7. But as soon as I hit 7, that problem doesn't work anymore. So in words, I can say that the numbers that work are any number greater than 1 or any number less than 7. Let me show you how to do this with algebra. It's much easier to do it with algebra. So if I'm thinking of a number, in maths, if you don't know what a number is, we just call it x. If I add 3 to it, what would I have? Well, I would have x add 3. X add 3 is greater than 4. So I'm going to write that down. So x plus 3 is greater than 4, but it's also less than 10. So I'm just going to write that as one inequality. So x plus 3 is greater than 4, but less than 10. This is what we call a compound inequality. So a compound inequality is an inequality with basically 2 inequalities in one. Okay, so to solve this, I'm just going to use that balancing method like what we've done for the last couple of lessons. Solve means find x on its own, but at the moment I've got x plus 3. What do I do to x plus 3 to make it just x on its own? Well, if I take away the 3, I'm just left with x. If I take away 3 from the middle part of my inequality, I must do the same thing to the left-hand side and the right-hand side. So 4 take away 3 gives me 1, and 10 take away 3 gives me 7. And this is how I would solve a compound inequality. So I'm just thinking I need x on its own. What do I do to all parts of my inequality to make x isolated, so make x on its own? Alright guys, so let's do some examples together. So let's do 4. If you're feeling confident, just pause the video and try them for yourself. If you're not sure, just leave the video running and I'll explain them one by one. Okay, so for the first one, solve means just find x on its own. So I've got 2x plus 3, but I just want x on its own. The first thing I'm going to do, I'm going to get rid of this positive 3. How do I make a positive 3 go away? Well, I'm going to take away 3. Right, because I've taken away 3 from the middle part of my inequality, I'm going to do the same to the left hand side and the right hand side. To get from 2x to just x on its own, I'm just going to divide it by 2. Okay, so my solution is x must be greater than negative 2 but less than 3. And this is my answer. Okay, next on we're going to do the bottom left one. Okay, so I don't want that 6 to be there, so let's take it away. Instead of 2x, I want 1x, so I divide it by 2. So my answer, x must be greater than negative 3.5 but less than 1.5. Alright, it's perfectly fine to have a decimal number in my answer. Okay, top right one. So, I don't need that positive 3 to be there, so let's take it away. Because I've taken away 3 from my middle part, I'm going to take away 3 from the left and the right hand side. Now, to get from 2x to just x on its own, I divide by 2. And this is my solution. Okay, finally, so 2x plus 6. Let's get rid of that 6. So I'm going to take away 6 from the middle, which means I take away 6 from the right hand side and the left hand side. And then finally, to get from 2x to x on its own, well, what's the opposite of multiplying by 2? Well, it's dividing by 2. So my answer is on my screen right now, and it's perfectly fine to have some decimals in my answer. Okay, so please could you find the worksheet that I've attached for you on Google Classroom. Give it a go, you've got your answers on there, and just let me know if you need any help with any particular questions. Alright, thanks very much guys.